Hello students, here is the question. The integral 2x minus 1 cos of root of 2x minus 1 the whole square plus 5 upon root of 4x square minus 4x plus 6. So if we look over here, we need to find the integration of these entire equation, and over here the C is told that it is a constant of integration. So what we can see is there is a term 2x minus 1 common in the entire equation. So we will put something in its place. We put 2x minus 1 square plus 5 to be equal to t square, that is this term to be equal to t square. And once we derivate it, we get 2 into 2x minus 1 dx is equal to 2t dt. Correct? Now once we have that, we can take this and this, because we have this, we just divide take cancel this 2 over here. We have 2x minus 1 dx is equal to t dt. We put that t dt over there. Cos of root of 2x minus 1 the whole square plus 5 becomes cos of t, because this is t square, so root of that will become t, and cos of the entire term divided by root of 4x square minus 4x plus 6. So that is, if you completely simplify or open up this square, that is 4x square minus 4x plus 1, it becomes 4x square minus 4x plus 6. So t cos of t by t into cos t by 2 dx dt. This is dt over here, there it is no dx, this is dt. Once we have that, we have cos of t divided by t into dt by 2 dt. So once we have that, we can see that it becomes 1 by 2 sine t plus c, and sine t becomes root 1 by 2 sine of root of 2x square 2x minus 1 the whole square plus 5. So the option is B. Thank you.